My name is Alfredo Terrazas, and today's date is 2/26/2021. This is my submission for CIRC01 Attempt A. In this submission, I will be using a digital pin with pulse width modulation to fade an LED in and out. Starting at the top, we will be assigning LED pin an integer data type and a value of 9 to correspond to digital pin number 9. We will be using this pin because it has the aforementioned pulse width modulation, also known as PWM. This pin function allows it to give analog results despite being a digital pin. Moving on the matter of void setup, we will not be using the command pin mode as it only corresponds to digital usage. So this source code will not be using the void setup code block. So moving on to the void loop, we will first write in values to give off the fade in effect. Starting over here, fade loop. Using the for command, we will make a statement that tells the microprocessor that if the value of fade value is equal to 0 or less than 255, which is the max, it will increase the value for that variable name by 5 points, essentially incrementing it by 5. We then make a new block using curly braces to use the analog write function on LED pin to set the range value for fade value from 0 to 255. Afterwards, we use the delay function to delay the fade effect for 30 milliseconds, allowing the LED to stay lit for a split second before the next code block takes effect. Closing this block, we then proceed to using the for command once again to make the fade out effect using the same method as the fade in effect, except we set the statement to decrease in increments of 5 if the value of fade value is equal to 255 or greater than 0. The same goes for the next code block that is written, which also sets the range for the fade value from 0 to 255 and delaying it for 30 milliseconds, mirroring the other code block's effect. That marks the end of the source code that gives the LED its fading effect. Now looking at the Arduino and breadbox itself, we can see the fade effect in play. And much like the other submissions, the components don't change too much. We have the red and black wire acting as the 5V and the ground connecting to the Arduino. We have the resistor connecting to the ground and connecting to the negative lead on the LED to give it power. We have the positive lead connected to the blue wire, which is connected to the already mentioned pin number 9, which, as you can see, has the PWM function. Using that function, we were able to go ahead and get the dimming effect using the source code that I had written. And this concludes my submission for CIRC01 Attempt A.